Okay, let's move on. And now I want to talk a little bit about absolute and conditional convergence. If we have a series and it looks something like this, there may or may not be positive or negative signs in here. So in the extreme case of alternating series, you know, we had a nice thing where it went plus, minus, but there might be other cases where it goes minus, minus, plus, plus, minus, minus, plus, you know, who knows what. Series of pluses and minuses. Okay, that's possible. But let's look at a closely related series in which the terms are kind of derived the same, but in this case, we're going to modify it. So now we add the condition. Oh, darn it. Put an absolute value there. I'm sorry for the mess. It's the sum of the absolute values of this series, okay? Now, if this thing converges, then that series is called absolutely convergent. And the term absolute comes from the absolute values. Now, if you think about that, that's a very stringent case because we're forcing all the signs to be positive, and yet it still converges. That means that any form of it that has at least some negative signs in, okay, will also be convergent. So this then gives us what is referred to as the absolute convergence test, which says that if this converges, that means that converges. Okay? Because this is a more difficult bar to get over for convergence. And if we know this is true, then this also must be true. And so this would be a way of maybe a simpler way, in some cases, to test for convergence. It may be easier to deal with where there's only positive signs. Okay, now if it diverges, let's say that it diverges, that does not necessarily mean that this term up here, this series up here, also diverges. It's only going to work when you get convergence means convergence.